Hello, this is Nitin Dahad with the Times. I'm speaking to Mahesh Tirupattur, who's the CEO of Analog Bits. Hello, Mahesh. Hello, how are you?
Hello, Nitin. It's lovely to be here in Cambridge, England.
So tell me, Analog Bits, I think, has been going for quite a few years. Some of the things I think which we see in terms of press releases and whatever, you know, you're sort of in the leading edge process technologies with your analog IP. Tell us just a little bit of context what that means. What's the significance?
Absolutely. Leading edge IP development is one of the key focuses of analog bits. And as we move to the leading edge processes, the challenges are very different. So, in the early phase of the FinFET, timing was always an issue. But today, power is a big issue because people are trying to conserve energy by managing power, and therefore that translates to better performance. So the problem sets are very different between some of the earlier FinFETs to where we are in gate-all-around technology in 2 nanometer. Additionally, all of these IPs need to be qualified on test chips because the cost of design for customers has increased enormously, and therefore having multiple revisions of test chips is extremely critical. So we work very early on with early versions of PDK, work with the foundry as partners, and make sure we qualify the first level of qualification, and we continue the process over an 18-month cycle, qualifying at about 3 test chips, and then the silicon comes back and the customer has seen 3 revs of silicon before they can start taping out.
But no, what your IP is doing is basically doing a lot of the power and energy management. Is that right?
That's correct.
For the AI and the data center.
That's correct. We are not only detecting power failures or potential power issues on the chip, but we're also helping customers correct. Now, why is that important? Is because all these AI and data centers, they need to optimize power at a granular level because they put hundreds of cores on a chip. And today, if you don't have granular level power management in a very fine manner, they cannot manage the overall power of the chip. So there are thousands of amps coming in, and these have to be carefully managed, and immediate instantaneous corrective actions have to be taken, and that's what we facilitate through our IPs.
So just to put it into context, your customers are developing these advanced AI data center chips, and you're providing the analog IP that enables them to manage some of that power and performance.
Absolutely, yes. Managing power translates to optimizing energy on the chip. That in turn translates to performance. So all these are highly connected events. So in the past, power and performance were detached. Today, power and performance are extremely highly coupled.
Okay. And so what kind of successes have you had so far in terms of that advanced process technologies and what you're doing?
Yeah, so we taped out our first test chip for N2 in April of last year.
That's a TSMC N2.
That's right, yeah. Sorry, I take it back. We taped out our first test chip in September of last year, and we taped out a second test chip in April of this year. And the first test chip performance looks very encouraging. The functionality is solid. The design margins seem to be very good. And now we're optimizing these IPs for new revs of PDKs and future revisions of where things are going to happen within the fab in the next couple of years.
And what does that mean for the customer?
For the customer, it's entirely risk reduction because these are very critical IPs. If a clock doesn't work, then the chip doesn't clock. If the power doesn't power up, you have a dead chip. So these are very important parameters that customers consider, that these IPs are silicon proven before they actually implement it in their own chip.
You've been doing this for a couple of decades where you've just been managing that in the various process technologies and leading edge process technologies. Is that right?
That's correct. So Analog Bits has been in business since '96, but we've been working on leading edge for the last maybe 8 to 10 years. And so this has been a constant cadence of how to qualify these IPs. IP companies like us not only need to have good design capabilities, which is fundamental, foundation building block, but we also need to have the ability to characterize these IPs on silicon and rev it multiple times and show the customers that the variations across these 3-4 revs of test chips is consistent and it's expected and predictable. And that's the level of commitment that we have on our IP business to make sure the customers are absolutely assured of their success.
And you were acquired by SemiFive a couple of years ago. Tell me a little bit about SemiFive and your relationship and where that's going.
Yeah. So in 2021 December, we got acquired. So January, we announced the acquisition
Okay.
of 2022. We've had a very symbiotic and somewhat independent way of operating our companies together. SemiFi believed in the IP business quite a bit. They saw us as a growing star in the IP business, and hope we have delivered to their promise and expectation. I believe we have, but we always could do more. And so we have been sort of the driving force on their growth path for a potential IPO that they have filed for. And so there is a symbiotic partnership because we are working on many IP blocks which pertain to AI and machine learning. And they are also doing ASIC chips for AI and machine learning. So any IPs that we develop here can be utilized by them, and they leverage most of our design capabilities.
And so they're doing an IPO in Korea?
That's correct.
In South Korea? And,
That's correct.
And what's their intention? What do they want to do?
Yeah. So obviously, any IPO ends up in a capital infusion into the company. So the purpose of this IPO is to make sure there's financial stability in the company, and second is to show a growth path to the investors. So there's a continuum of an investment that comes along, and the third thing is to retain talent and also do any strategic acquisition, both from their design capabilities to enhance their abilities to design more chips, and also for us to develop more IPs and feed the ecosystem into them. Analog Bits is a global company. We supply to pretty much all companies around the world who are doing semiconductor chips. SemiFi is leveraging our IP reach to potentially help with the design reach as well for customers who might need it. So yes, they certainly are trying to have a global footprint, and using Analog Bits as a good leverage point is nothing but a good thing for them.
So what's next for Analog Bits as part of SemiFive, but also what you're up to in the next few months?
Very good question. I keep asking the same question myself, and I keep saying what I should be doing more.
Yeah, you just became CEO earlier this year, so
That's right.
Yeah.
I'm really truly enjoying being the CEO of the company. First, I'm extremely inward focused as well, getting some discipline in terms of the product development and communications, and really building a team spirit where we build the company based on team, technology, serving customers. That's kind of the three missions that I've set. And some of the new products that in the pipeline are very exciting and solving some of the problems that customers have not encountered before, but they need a solution. So we're coming up with numerous power management and power delivery IP. Obviously, you will hear some of it at the TSMC OIP, which is coming up probably in Santa Clara in a few months.
I think one of the things when you talk about power management, we're not talking about PMIX, we're talking about beyond that. We're talking about smart energy management. Is that right?
Absolutely. PMIX are sort of external components where the chip says, I need this, do that for me. Whereas here, we are actually dynamically helping customers manage power on die. So these are independent blocks which are designed for advanced processing. LDOs, detectors, fast current sensors, helping customers throttle both power and clock concurrently.
And isn't that a big problem for a lot of the AI data centers in terms of power, glitches and all that? Is that right?
Yes. These are absolutely real-time problems that cannot be simulated by any simulator, and these sort of show up in silicon. And when these things show up in silicon, customers need to not only identify but to correct. So glitches and power supply variations, and also ability to manage the power feeding into many of these blocks is extremely critical.
So it's kind of a smarter PVT enablement.
It's a smarter sensor, and in both for process voltage, temperature, and as well as mainly for dynamic voltages as well.
Well, Mahesh, thank you very much.
It's a pleasure, Nitin.
Thank you.
Thank you.